C2, differentiation, application of differentiation to real-life problems. So, here we're asked to consider the following problem. A farmer needs a rectangular area of 36 metres squared, and we're asked to find the lengths of the sides so that we use the smallest amount of fence. So, this is a minimising function. We're trying to minimise the amount of fence used. So here we are given step-by-step instructions on the best way to answer this question. So the first thing we need to do is draw a diagram. And we're going to label the sides X and Y, because opposite sides in a rectangle are the same length, and we know that the area of this is going to be 36 metres squared. So we'd be able to find the area by doing x times y, which we know would be equal to 36. So we're going to rearrange this to get it so that we just have y equals, and y would equal 36 over x, because when we find an equation for the perimeter, we will need to get rid of the y's so that then we can differentiate it with just x's. So the perimeter could be found by doing 2x plus 2y. But of course now we need to substitute in y equals 36 over x, which would give us p equals 2x plus 2 lots of 36 over x, which is the same as p equals 2x plus 72 over x, or 2x plus 72 x to the minus 1. So now we can differentiate the perimeter, because remember we're trying to find the minimum perimeter. So we can find a stationary point at dp by dx equals 0. So we need to find dp by dx. So if we differentiate the first term, that'd give us multiplied by the power, reduced by 1, that'd just give us 2. And then multiplied by the power again, that'd give us minus 72x to the minus 2. So we want to find where 2 minus 72x over x squared is equal to 0. So I'm going to move the 72 over x squared to the other side, which will give us 2 equals 72 over x squared. And now I'm going to divide through by 2 and move the x over to the other side, which would give me x squared equals 72 over 2, which is the same as 36. So to find x, I need to square root both sides. So of course that'd give me a positive and a negative square root. But remembering that we're finding lengths here, we cannot have a negative length, so we find that x is just equal to 6. So we need to find out if this is a maximum or a minimum point in the curve which is described by the perimeter. So we can do that by doing d2p by dx squared. So we need to differentiate this term again. So that'll be done. So the 2 disappears, and we're just left with 144x to the minus 3. So we need to substitute in x equals 6 to find out what sort of a stationary point we have at x equals 6. So substituting in x equals 6, that's 144 over 6 cubed, which is the same as 144 over 216. And of course, because both of them are positive, we end up with an answer that's greater than 0. Therefore, we have found a minimum point at x equals 6. So we need to find out what y is equal to when x equals 6. So remembering that y equals 36 over x from up here, we can see that when x equals 6, y equals 36 over 6, which gives us a y equal to 6. So we actually end up with a square which has sides x of 6 and y of 6. So 6 by 6 square. So that would give us an area of 36 metres squared. But what perimeter do we get? So that would be 4 times 6, which gives us a perimeter of 24 metres in this case. So you can see that we've used a real-life application of differentiation to see that we have found the minimum fence needed to make a 36-metre squared area. Following these steps will help you to find the answers to real-life differentiation problems.